In this section, we are going to solve the rational equations and look at the applications. For a rational equation, it is an equation that contains at least one rational expression, while any non-rational expressions are polynomials. To solve this kind of equation, first step, we are going to multiply each term in the equation by the LCD, or the least common denominator. And this step will convert the rational equations into polynomial equations. And then the last step, we're going to exclude extraneous solutions, which are the values that cannot possibly be solutions of the equation. Another way we can say that the solution that make the terms undefined. And basically is from the denominator equals 0. Let's look at the examples. The first example, for number 1, solve the following rational equations. In part A, we have the left-hand side rational terms as 1 over the quantity x minus 2 added by 1 over x minus 1 quantity equals 3 over x minus 1. We have the rational terms where the denominator cannot be 0. So we're going to set on the side for the set of the extraneous solutions, or when the terms not defined or undefined when x minus 2 is 0. That means when x equals 2. And for the second rational term, denominator x minus 1, if x minus 1 equals 0, therefore x gonna be 1. So these two numbers are called extraneous solution. That means we do not include these solutions as a solution set of this equation. To solve this, first we're gonna look at the LCD, or the least common denominator. For the denominators x minus 2 and x minus 1, the LCD, or the least common denominator, would be the product of these two factors. So we're gonna multiply all terms by the LCD. Write the original in different colors. This way, we can see that the denominator of each term will be reduced with one of the factors of the least common denominator. Then we're gonna get x minus 1 for the first term added by x minus 2 for the second term equals, the right hand side gonna be 3 multiplied by the quantity x minus 2. Next, we take away the grouping symbol. X minus 1 plus x minus 2 equals 3x minus 6. At this point, the rational equation disappeared, and we have the polynomial equation instead. Then we're going to collect like terms. Left-hand side, x plus x becomes 2x minus 1 minus 2 becomes minus 3, where the right-hand side is 3x minus 6. So we have 2x on the left, 3x on the right-hand side. I'm going to subtract 2x both sides of the equations by moving the x term together. And then the left-hand side now is negative 3. The right-hand side becomes 1x minus 6. And then add 6 both sides to get the equations like positive 3 equals x, or x equals 3 as a solution, where the extraneous solution x2 and x1. So we're going to put the notes here where x cannot be the value 1 and the value 2. For this example, y over y minus 4 minus 9 over y plus 8 equals y squared divided by y squared plus 4y minus 32. each term, we're going to make a list for the extraneous solution or the solution that could cause the term undefined. For the first fraction, denominator is y minus 4. That means if y minus 4 equals 0, we're going to have y equals 4 as one of the extraneous solution. Y plus 8 for the denominator of the second term, if we let it be 0, y equals negative 8 would cause this term to be undefined. And for y squared plus 4y minus 32 equals 0, it can be factored to be y plus 8 times y minus 4. If we let it be 0, this polynomial expression in a factor form would give us the same two numbers as before, as y equals 4 and y equals negative 8. Therefore, we make a list for the extraneous solution, or the solutions that we have exclude from the set of the solution as y equals 4 and y equals negative 8. For the LCD, or the least common denominator, in this problem, it's going to be the product of y minus 4 and y plus 8. So for the problem, write the original one, y over y minus 4 minus 9 over y plus 8 equals y squared over, and write in the factor form as y plus 8 times y minus 4, and then multiply each rational expression by the LCD, which is y minus 4 times y plus 8. So we reduce the common factor, y minus 4 for the first one, y plus 8 for the second one, and both factors for the term on the right hand side. So now we have y multiplied by y plus 8 for the first term, minus 9 times y minus 4 for the second term, equals y squared on the right hand side. At this point, we get the polynomial equation. And then we're gonna solve as before by distributing y to the parentheses and 9 to the parentheses for the second term. That y squared plus 8 times y minus 9y plus 36 equals y squared. And then collect like terms, or move all the terms together in one side. We subtract y squared both sides of the equation. So y squared and y squared reduce, and then 8y minus 9y becomes negative 1y, and then plus 36 equals 0. That means we have y equals 36 as a solution, and y equals 36 is not the same as the two exponent solutions. So we put the note here, as long as y is not the value 4 and y is not negative 8. So we are good. For this example, we have negative 2x divided by x plus 3 subtracted by 3 divided by x plus 2 equals negative 2. As we notice, the all terms contains negative sign. So we are going to multiply all by negative 1 to make the problem less complicated. Therefore, we get 2x divided by quantity x plus 3 added by 3 divided by the quantity x plus 2 equals the quantity 2. And then on the side, we're going to make a list of the extraneous solution, or the number that make the term undefined. The first fraction, or the first rational expression, if x plus 3 equals 0, x equals negative 3, gonna make this term undefined. X plus 2 equals 0 for the second term. That means x is negative 2, gonna make the term undefined. So we have two extraneous solutions. Next, for the LCD, or the least common denominator, for this problem, gonna be the product of the factors x plus 3 and x plus 2. So next step, we are going to multiply all terms by the least common denominator. So multiply by the quantity x plus 3 times x plus 2. And then cancel the common factor, x plus 3 for the first, x plus 2 for the second. And next, our equation becomes 2x multiplied by the quantity x plus 2, 3 multiplied by x plus 3, and on the right hand side is 2 multiplied by the product of x plus 3 and x plus 2. The next step, we are going to distribute the terms and then look for the like terms for x eventually. For the right hand side, the expression x plus 3 times x plus 2, that would give us the x squared plus 5, x plus 6. So multiply 2x to the x plus 2, 3 to the x and 3, and then 2 to the 3 terms in the quantity. Then we get 2x squared plus 4 times x plus 3x plus 9 equals 2x squared plus 10x plus 12. And then on the left hand side, we have two like terms, 4x and 3x. Now we get 2x squared plus 7x plus 9 equals 2x squared plus 10x plus 12. Next, we're going to subtract 2x squared both sides by collecting all the terms together in one side. 2x squared cancel. For the 10x on the right hand side, we subtract 10x both sides. Then we get negative 3x on the left added by 9 equals 12. Subtract 9 both sides to get negative 3x equals positive 3. Therefore, the x equals negative 1 from dividing both sides by negative 3. As x equals negative 1, that's a good solution because it's not one of the exponent solution. Bx equals negative 2 and negative 3. So this, we have to exclude it out. So we just put like x cannot be negative 2 and negative 3.